second module, we discussed the downside of saving date time as character or string in R. One of the main points we discussed was that we can't extract date or time components such as year, month, hour or minute, etc. from the date or time object. Now in this module, we'll learn to extract date time components such as year, month, date, week, day, quarter, semester, hour, minute, second, and time zone, right? So you have the date components, you have the time components, and on top of that we also have quarter, semester, and other information that we can extract, right? So this whole module is about extracting different components from date and time. So we'll get started with year, month, and week, right? So let us create a date object. Okay, we'll do that here. Do that as release underscore date, right? And we'll use one of these helper functions from lubridate. So you have 2019-12 08 05 03, right? Pretty much we are sticking to the same date throughout the course, right? So that you don't have to worry about different dates. We are just looking at how this date can come in different formats, right? So that you learn how to store them, parse them, and format them, and what are the different type of operations that you can do on date and time, right? So let us create this date object, right? So we have it in the ISO 8601 standard. Let's start off with year, right? So use the year function from lubridate and then pass on this date object, right? So we'll use the same date object throughout this module. What will change is the functions that we are using, right? So when we are extracting different components, we'll end up using different functions. So let us start with year, right? So you have the year extracted here, which is 2019. Next we'll start with month, right? So we extracted year. Now let us move on to month. Okay, and in month we'll look at a few different variations, right? So let's start off with simple extraction of month from release underscore date, right? So it shows the month is 12, that is December. Okay, now here it is in the format of a number. The month is in the format of a number. Instead, if you want it in its abbreviated form, right, then you can use the label argument, right? Same function, we'll just add an additional argument here, label, and set it to true. It's set to false by default. Now when you set it to true, instead of the number, it is giving you the abbreviated form, right? Instead of 12, you can see this now, DEC. Now if I want the full name of the month instead of the abbreviated name, then what we can do is can take this code here and set abbreviation to false, right? So by default it is true, it will return the abbreviated form or name. Now when you set it to false, it will return the full name. So here now we have December. Okay, now we can see the full name of the month. Now months from base R, there's a months function from base R will return the full name of the month by default, right? Here month doesn't do that. It will first return the month in the format of a number, then it will return the abbreviated form, and finally we see the full name of the month when we set abbreviate argument to false. If you use months from base R, then you can see that it will return the full name of the month, right? So you can choose to use any of this variation. You can use months from base R, or you can use the month function from lubridate, depending on whether you want the full name of the month, the abbreviated form, or the month represented by a number. Now let us look at the week, right? Week returns the number of complete 7-day periods between the date and 1st January plus 1, right? So you take the date and then you take 1st January. Okay, now week will return number of complete 7-day periods, right? So number of 7-day periods between 1st January and the date, and then it will add 1 to it. So let us see what it returns for our release date. Right, it returns 50. So there are 49 complete 7-day periods between the date and 1st January. Okay, so if you find the need to use this, you can go ahead and check it out. Great, now we'll clean the output here and move to extracting day from the date component. Right, now day has several variations within it, right? So day will give you the day, and then M day will give you the day of the month, W day will give you day of the week, Q day gives you the day of quarter, Y day day of year, and then weekdays also gives you the day of week, and days in month gives you the number of days in that particular month from that date, right? So let's try all of this. We'll see what's the output from each of this. So day should give you the day, so that is in our case 12, because the date is 12th December 2019. M day we said is day of month, so again it should be the same output, right? It's the 12th day of December. Then we have day of week, right? So day of week is 5, so it's the 5th day of the week. Okay, and then you have Q day, just the day of the quarter. So it takes the quarter in which the day comes and gives you the day of the quarter. So it's the 73rd day of that quarter. Okay, so you have October, November, December, which is a quarter, and this is the 73rd day of that quarter. And Y day gives you the day of the year, so this should be 346. So it is the 346th day of the year 2019. Okay, now I'll come back to W day again, because it can return a number and it can return abbreviation of the weekday or full name of the weekday. So this is similar to month, right? There we saw that month returned the month in the format of a number first, then the abbreviated name and the full name. So W day can do the same. First it will give you the day of the week, so this is the 5th day of the week. Then you can take this code here, then use the same argument, label is equal to true. Now it should return Thursday, right? So start from Sunday, Monday, Tuesday, Wednesday, Thursday. So that is the 5th day, right? So here it was 5, and now you can see THU, which is the abbreviated form for Thursday. And if you set abbreviation to false, you should be able to see the full name of the day. So now it is Thursday, right? And this option is there with W day. Now weekdays from base R also returns the day of the week, the name and not the number, right? So it will return the name and not the number. So if you want the abbreviated name, use the abbreviate argument, right? So let us check out weekdays from base R, right? So it doesn't return the number, it returns the full name. And if you want the abbreviated name, in this case you have to set abbreviate to false. Right, now in case of W day, we saw that by default it will give you the day of the week first. That's the number, right? And then if you set abbreviate to false, it will give you the full name. So their abbreviation is the default. Here full name is the default. And there's one last function that we'll see with respect to day, that is days in month, right? So if you want to know the number of days in the month, then you can use days in month. So in our case, the month is December, so it has 31 days, right? So it returns the month and the number of days in that month, right? So this is with respect to day. Now we'll look at hour, minute and second. Okay, so we have moved out of the date component. Okay, now we'll look at the time component. So start off with hour. Okay, so this should give us 0h. Okay, sorry, I made a mistake here. Release underscore date. Okay, so hour should return h, minute will return 5, and second will return 3, right? Because our time is 12th December 2019, 080503, right? So it has extracted the hour, minute and second. Now there is another function which is seconds. Okay, and this is also from lubridate, this is not from base R. What this does is it will give you the number of seconds since 1970 January 1st, right? So remember the origin that we talked about in the second module, that is how R stores date and time, right? So in case of the date class, it was number of days since 1st January 1970. In case of POSIX-CT, it was number of seconds since 1st January 1970, right? So here you can see that seconds also gives you the number of seconds since 1st January 1970. Right, now what we'll do is we'll move on to the next part, which is quarter and semester, right? If you want to know the quarter within which the date falls, or if you're looking at more from an academic perspective and you want to know the semester, then you can use the quarter and semester functions. So quarter will return the quarter from the date. So December is in the 4th quarter, so we should see 4, right? Yeah, so you can see 4. Now if you want the year along with the quarter, then you can use the with underscore year argument and set it to true. Here we only see the quarter, right? Now you want the year also, then use with underscore year and set it to true. Right, so now you can see the year first followed by the quarter. Now in India, the fiscal starts in April and December falls in the 3rd quarter. Now how do we accommodate this change, right? So what we can do is in the quarter function, we can use the fiscal underscore start argument, and it will allow us to set the month in which the fiscal begins. Now since in India the fiscal begins in April, we will use that particular argument, right? And then we'll set it to 4, which is the month of April, right? So according to India, December should be in the 3rd quarter, right? And you can see, so you can change the fiscal, the month in which the fiscal begins, and accordingly the month in your date will move into that particular quarter. Now there's a function in base R as well, which is quarters, okay, and it will also return the quarter, but it returns it in a different format, right? We'll see it here, right? So it returns as Q4, right? Instead of just 4 or with quarter, it returns it as Q4, right? So we have covered the year, then we covered month. We looked at different ways in which the day of the week, day of the month, day of the year can be retrieved. Then we looked at the time component, hour, minute and second, and finally we also looked at quarter and semester. Now we'll move to the case study, right? So we'll go back to the case study, and what we'll do is we'll use some of the functions that we have learned here to answer a few questions from the case study. So the first thing we want to do is we want to extract the date, month and year from the due date, right? So let us take the data set, which is transact, okay, and then we'll use mutate from dplyr, right, and create 3 new columns. So first is due underscore day, right, where we are extracting the day from the due column, okay. Then we have due underscore month, okay. So this will be from the due column, we'll extract the month. Then you have due underscore year. So here we'll extract the year from the due column. Let me just fix this. Okay. Now let us run this, and you can see the 3 new columns here, right? Due day, due month and due year. So takes from here 125 to 12. The month is extracted from here, and the year is all 2013. Good. Now let us do some basic data sanitization, right? In the case study, what we want to look at is if the due day happens to be February 29, right? So the due day for the invoice is 29th February. We want to ensure that the due year is a leap year, right? Because February has 29 days only when the year is a leap year. So this is a basic data sanitization that we are going to do. If the due date is on 29 February, then the year must be a leap year. So how do we do this? What we can do is we'll first extract the following from the due date, that is due day, month and year. Then we'll create a new column called is underscore leap, which will be set to true if the year is a leap year, else it will be set to false. Then we'll filter all the payments that fall on 29 February, where that is all those rows in the due column where the value is 29 February, and then we'll select the following columns, that is due column, where we see the date, where we see whether it is a leap year, that is the is underscore leap, right? So we'll do some basic data sanitization. First step is extract these. We'll take this column, this code from here. We're going to use the same one here, right? Due day, due month and due year, okay. And we'll add one more column, which is underscore leap, okay, and that is leap underscore year, leaves the due underscore year column here, which we just created, right? We extracted the year from the due date column, okay. Next thing that we'll do is we will filter all those rows where the month is February, that is due month is equal to 2, and the day, that is the date of due date, is 29, right? So the month is February and the date is 29. So we are filtering out all those rows where the payment is due on February 29th, okay. And then he'll select the due date column and is underscore leap, right? So we'll look at this output, then you'll understand what we are doing, right? So we said that if the due date falls on 29 February, then we have to check whether it's a leap year or not, right? Now since all the due dates fall in the same year, which is 2012, and we can see that the value in the is_leap column is true, now we can be sure that the data is clean, right? So if the due date is on 29 February, it is only in the year which is a leap year, right? Since here all the payments are on the same day, which is 29 February 2012, and since 2012 was a leap year, which we can see in the is_leap column, we can be sure that the due date is correct, right? So this is a simple example of how you can use these different functions for ensuring that your data is correct, right? Now we'll also look at one more example, right? Before we move on to the next module, let us look at one more example, right? This is invoice distribution by quarter, right? How many invoices are due in each quarter, right? So again we take the transact data set and we create a new column. Okay, so in this new column we call it as quarter_due. Okay, that is the quarter in which the payment is due. We use the quarter function and we pass on the due date to this function, right? From this we get the quarter in which the payment is due, right? And then we use the count function again from deep layer and we pass on this column, which is quarter_due, which we just created. Now let us look at the output, right? So we know that 521 invoices are due in the first quarter, 661 in the second quarter, 618 in the third quarter, and 666 in the fourth quarter, right? So now we know quarter wise how many invoices are due for payment, right? So these are some simple use cases of how you can use these functions from lubridate and BSR for quick data analysis. Now we have a few practice questions for you. Let us see them. So you have to use the R versions package, okay, and then get the R release dates using R_versions function. Okay, I'll quickly show you how it looks like. So install the R versions package and then get R release date using this function R_versions, right? So here you can see the R version number, the date on which it was released. So that has the date component as well as the time component, and the nicknames start from I think 2.14 version 2.14. Okay, so we want you to use this function, that is R_versions, from the R versions package, and then you have to extract the year and tabulate it. So you have to say how many releases happened in each year, how many releases happened in which month, in which weekday, that is in how many releases of R have happened on Monday, on Tuesday, on Wednesday, and by hour and quarter, that is how many R releases happened in each quarter and what is the hour at which it gets released. So we know that R 3.6.2 was at 8 in the morning, right? The hour is 8. So see how many releases happened at 8, at 9, or is there a particular pattern, right? It happens in the morning or night or something like that. So you have to extract the hour and then you have to tabulate it. Similarly, you have to do it for year, month, weekday, and quarter. Okay, so that brings us to the end of this module. In the next module, we'll learn how to create dates using a different set of functions again, how to update different date or time components, and how to create a sequence of dates, right? So we look at a function called sequence.date, and we'll see different variations of that function to create a sequence of date, and we'll also learn how to verify or test the membership of objects to see whether they belong to the date class or to the POSIX CT class or POSIX LT class.
I hope you have enjoyed listening to this video. Please be kind enough to like, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos on our playlist, and subscribe to Rsquared Academy channel to learn more. Happy learning!